Welcome back, everyone. With this video, I will continue to discuss the basics for completing a linear programming model using the Excel solver. This is the second video in the two-part series on linear programming using Excel solver to solve a basic optimization problem using the Galaxy Industries example. This video focuses on how to set up and complete the optimal solution for a company with limited resources. For this video, I continue to use the Galaxy Industries example from the book Applied Management Science by Lawrence and Pasternak. In the first video, we prepared the information for input into Excel. In this video, we'll begin where we left off with the frequency table. As you can see, I transferred a copy of the mathematical model that we produced from the first video in a text box to help us to see how to enter that information into Excel. Now we're going to set up the spreadsheet with a heading in the top cells. In this case, we're going to title the table Galaxy Industries. This is more of a professional format step than a step necessary to solve or calculate the answer. It just helps to keep everything straight when we correctly title the cells. The next step is to provide a place for solver to identify the number of toys to produce. We normally put this section at the top of the table, but we enter it into the second data box in solver. I'll show you what I mean when we get to that point. So right now what we've got is we place the cells for the total number of product in row 4. So we've got dozens of space rays in cell B4, and it'll be dozens of zappers in cell C4. Now we're going to leave them blank as solver fills these in for us. Next, we need to identify the constraints under which Galaxy operates. These come from the mathematical model that we designed earlier. We're going to place the items in the column associated with the variables we identified. Now remember, we identified x sub 1 as space ray dozen toys and x sub 2 as zappers the dozen toys. Essentially, you can visualize it as the column B for all of the x1 variables and column C for all of the x sub 2 variables. Now we're going to add titles to two cells to complete the format for the table. We're going to put the titles total and limit in cells D5 and F5. Now you'll notice that we leave column E5 blank for the relationship between the constraints. You'll see how these figure in when we enter those constraints. Now we can enter the constraints under which the company will operate. We said originally that what we're trying to do is to maximize profit. And you'll notice the equation was max 8 times the number of x sub 1 space rays, dozen space rays, plus $5 times the number of x sub 2 zappers. So since we're trying to maximize profit, we enter the $8 per space ray and $5 per zappers. To identify the total. Now what we're going to do is we're going to use a sum product function in cell D6 to calculate the total values. and you'll notice it's the equal sign, sum product, and it's the sum product of the cells, the number of space rays, the number of zappers, times the profit from each, sum product here. And you'll notice that we need to include the dollar sign before any cell or any cell designation we don't want to change when we drag the function down. You'll see what I mean as we complete the table. Now we're going to enter the remaining constraints and their limits. For the plastic constraint, we had 2 x sub 1 and 1 x sub 2. So we title it plastic, 2 pounds per space ray dozen, 1 pound of zapper dozen, and then we're going to come over here to the limit. And you'll notice that the plastic constraint is that we had the amount of plastic we have per week is less than or equal to 1,000 pounds. And we put them in separate cells, and you'll see why as we complete the process. The next constraint that we've got to add is the time constraint. And for the time constraint, we had 3 minutes per dozen space rays and 4 minutes per dozen zappers is less than or equal to, and we had 2,400 minutes. Now, since the sign is the same as for the plastic, all I've got to do is grab and drag that cell down, and it duplicates the information in the cell above it. The next constraint we have to enter is the total number. And you'll remember that the total number, dozen, of the space rays and zappers has to be less than or equal to 700. Right there. The final constraint we enter is the mix. Remember they said that we can have no more than 350 dozen difference between the number of space rays minus the number of zappers. Now here's where we enter the negative value since the equation involved subtraction. The last step is to complete the column D by dragging that function cell D6 all the way down to D10. And you'll notice that since we put the $B, $4, $C, $4 for those cells not to change, that for profit it multiplies times B6, C6. For plastic it multiplies times B7, C7. For time, B8, C8. Number, the total number times B9, C9. And for mix, the total number times B10, C10. So we've verified that the function copied correctly in all the cells. And of course, it's always a good idea to verify all the numbers in the spreadsheet so that they match the values from your objective function and constraints before you enter the values into the solver add-in. These values appear correct, so on to the next step. Of course, it's also a good idea to save your work periodically, as you do not want to have to go through this process all over again in the case of a gremlin attack. Assuming that you've already activated the solver add-in, and if you haven't, see the video about activating the solver add-in for linear programming before you go any further. Once you have the solver add-in activated, open the solver data parameters box. Now I'm using Excel 2013 in this example, so the solver add-in is located in the data tab. So the data tab, solver add-in. Now you'll notice that this particular input box is a bit different than the one in the book and from previous versions of Excel, but the boxes are essentially the same. All right, we're going to begin by focusing on the box identifying the objective function. And you'll notice that what we want to do is we want to make sure that the box, that the cursor is blinking in the box and that the box is empty. We're going to focus on the box that's identified the target cell or the objective for the later versions of Excel. Ensure the cursor is blinking, and for the objective we want to maximize profit. So what we're going to do is we're going to enter the profit cell into the set objectives box. I'm going to minimize the parameters box, and we're just going to go down to cell D6 profit, total profit, and click on it. And you'll notice it automatically enters into the parameters box. We want to make sure that the max button, radio button, is on, and we're going to move to the changing variable cells box. Here is where we enter the cells that are going to affect the total profit, and that's the number of each product manufactured. We're going to ensure the cursor is blinking in the data input box, the box is empty, and we're going to choose the cells for the total number of toys manufactured, which is B4 and C4. You see it transfers into the box. Now we're going to enter the constraints. I'm going to show you two methods to enter the constraints. The first is entering each constraint as a separate entity, and the second is more of a time-saving method where you enter all the constraints with the same sign at the same time. You do not need to use the more advanced method until you feel at ease with the process. So first, each constraint one at a time. We're going to click on the Add button to the right of the Subject to the Constraints box, and we're going to enter the cells applicable to each constraint. And you'll notice it's got the add constraint, the cell reference, the sign, and the actual constraint. So the first constraint that we're going to look at is the plastic. And the plastic constraint, total plastic constraint, is D7. The sign is less than or equal to, and the limit is 1,000. You can choose the correct relationship, click OK, and you can see it actually in the cell identification that happens in the constraint box. Right there. We're going to do this for each constraint. So the second constraint is time. We click in the time box, recognize the less than or equal to sign, and click on the 2400 for the constraint. Now, I could go OK and look at it, or if I click Add, it automatically puts it in the box and allows me to go to the next constraint, which is number. I look at the sign, less than or equal to. I click on the constraint, 700. We go to the next constraint, which is mix. Again, total mix, recognizing the sign and the overall constraint. We click OK, and you'll see all the constraints are listed in the subject to the constraints box. We want to check that all cell identifications are correct and verify the options under which you want to calculate the answer. For these problems, we assume a simplex LP or linear problems option. When you choose this option, we can generate the what-if reports, the sensitivity and answer reports as a final step. Now you're ready to calculate the maximize function for this problem. You click on the Solve button to calculate your answer. When Solver finds a solution, it gives you this box where it says it found a solution and all constraints and optimality conditions are satisfied. We want the answer and the sensitivity reports, and then we click OK. If Solver doesn't find a solution, the program will tell you and the reports box will be grayed out and you can't choose it. We've chosen answer and sensitivity boxes, and we click OK. Now the results are automatically shown in the cells. So our optimal number of space rays is 320 dozen and zappers 360 dozen. The total profit is $4,360, and then we check each limit. We'll notice that the plastic limit of 1,000 pounds is less than the 1,000 that we had. The time that we used, 2,400, was less than or equal to the time available. The number that we produced was 680 dozen, which follows under the 700 constraint. And the mix, there's a difference of 40 dozen, which is less than 350. Now the reports show on a separate worksheet. You can access these reports by clicking on the tab at the bottom of the worksheet. Here's the answer report. And the answer report helps us to determine the slack for each constraint and whether or not the constraint is binding to the outcome. The status is binding if there is no slack and not binding if there is slack. The sensitivity report tells us what happens if we change the constraints for the objective function. This is a more advanced report, and it's one that's probably best discussed in another forum. Now the last thing I want to show you is how to enter in all liked signed constraints at one time rather than entering each constraint. So going back to the solver box, I'm going to delete all of the options that we put in there. And we're going to re-enter them all at once. Okay, so now we're going to add, click on the add button, and now what we're going to do is enter in all the cells with the like sign. So all of these cells we've got are less than or equal to, so all we've got to do is highlight the cell from, in this case, plastic down to mix all at once. So it says D7 to D10. All of them have the same cell, and we just have to go over here to the constraint and highlight all the way down. Click on OK, and rather than each cell listed in the constraint box, you'll notice that we have a series of cells and a series of constraints. No different to solve it, and the answer comes out the same. I hope this video makes the linear programming process and understanding word problems a bit easier. Please see the video on linear programming for production scheduling, the video on production optimization, and the video on financial investing for more information on how to use Solver to help you make your decisions. I'd love to hear from you, so please send me feedback or any requests for videos that you'd like to see to my email, theprofessor@professornito.com, or visit my website for more information and training opportunities. Have a great day, and as always, happy calculating. We'll see you next time.